Hey everyone, I'm back with the angles and arcs stretch. The stretch has some great explanations of the concepts in a very succinct way. I recommend you read through it after watching this video. Let's get to it. Before we start the problems, however, let's go through some of these definitions over here. So, although you guys can read through it, I would just want to leave you guys with some examples. So first off, let's look at a second. An example would be AX because it intersects at 2 points, namely A and D. Next, we have a chord. A chord has the line on the endpoints, so AC in figure 1 would be a chord because A and C are on the circle. A tangent isn't shown, so I'll draw a quick diagram. And we just draw a line so that intersects only in one place. Let's say it's over here. And if we draw the center, we see that this will be perpendicular. So next we have central angles and inscribed angles. A central angle, as the name suggests, must have the center as one of the 3 points, and this angle is also the same as this arc. So if this angle is x, arc AB is also x. An inscribed angle is slightly different. All 3 points are instead on the circle, and there's a slightly different formula. If we say that this angle is here is x, this arc length here is 2x. Finally, we're at major and minor arcs. So a major arc is the arc that's greater than 180. So AB going this way is a major arc, but if we just took the short way, this would be the minor arc. So now let's get into problems 239 and 240. So for problem 239, let's have a look at the question. Quadrilateral ABCD is inscribed in circle Q, as shown, with diagonals intersecting at X. If the measure of angle AB is 110 and the measure of angle BC is 60 degrees and AB is equal to BD, what is the measure of CXD? So really quick, these M's mean minor arcs, so we don't want to take the long way around, but the short way. So let's start by looking at some of the arcs we know. We know that AB is 110 degrees and BC is 60 degrees. It's always helpful to look for inscribed or central angles when dealing with arcs, and we want to turn things into angles. As we can see, angle BDA is equal to 110 over 2 because of this, since it's an inscribed angle. So we say this is 55, and doing the same thing with BAC is equal to 60 over 2 is 30. Now, since we know that AB is BD, we can infer that angle BDA is equal to angle BAD is equal to 55, since we already know BDA. So that means angle CAD is equal to 55 minus 30 is 25. All right, so now we need CXD, and since we know CXD is equal to 180 minus angle AXD, we can calculate AXD. And we know that the sum of an angles in the triangle is 180. So we already have 2 angles in triangle AXD. So let's find the last angle. Angle AXD is equal to 180 minus the sum of 55 and 25 is 80 is 100. So we can calculate CXD to be 80, and that's our answer. Let's move on to problem 240. So circle P is internally tangent to circle O at A, as shown. AC and BE intersect at F, which is also the point of tangency between BE and circle P. AD and BE are diameters of circle O, and AG is the diameter of circle P. If the measure of minor arc CD is 50 degrees, what is the measure of minor arc BC? So let's write down the only arc we know, 50, and using some inscribed angles, we'll go pretty far. So we know that angle DAC is equal to 25 because it's an inscribed angle. And we also know that by this arc GF is 50. And since AG is the diameter, we know that this is equal to 180 degrees right here. This is arc AG. So we know that since the arcs sum up to 360, arc AF is equal to 180 minus 50 is equal to 30 degrees, 130 degrees. And since this EB is a tangent to circle P, we can say that AFB is 65, or 130/2. 180 minus that is equal to 115. Now we add these up to solve for angle AOF, and we'll subtract by 180. 180 minus 140 is 40 degrees. So this is 40, and since this is a central angle, we find that ED is 40. And again, EB is also a diameter, so we know that this is 180 minus 40 minus 50 is 90. So that's all I have to solve with you guys today. The links to the stretch and the answer key will be shown in the last slide of the video. Thanks for watching, and please leave a like if you learned something new from this video, and subscribe for more math count stretches. Bye!